In this video, we're going to be looking at some examples of using our exponential laws. Now, if you are familiar with the laws and you're feeling comfortable, then what I'd like you to do is to, when I write out the example, to copy it down and then just press pause on the video so that you can test yourself and see if you are getting the right answer. So in the first one, we're going to start pretty basic and then we're going to take it gradually and get it a little more complex. Okay, so here we have same base. So we know we're going to be able to use our same base rules. And in the first one, this is a power raised to a power. So what we're going to do here is multiply the exponents. And then we have just these. I'm going to leave these as they are. Now we have same base multiplication. So we're going to write down the base and then add the exponents. So when we add the exponents, we are going to get, and this is what I don't want to see. You should not be writing this and then giving an answer. I don't need to see that. Okay, what you need to do is just either do some mental math and add them in your head or take out a calculator and add them using your calculator. But what we're going to get is a to the negative 2. Now, if you recall, in our other video, I mentioned that when we work with exponents, we always want the answer expressed as a positive exponent. So this a had a negative 2, so we are going to take it to the bottom, so into the denominator, and now it's 1 over a squared. And that now is your final answer. So I'm going to call this example A. Just move these over a little bit. There we go. Okay. So for example B, okay, so 5 is not touching the exponent. It's not affected by the exponent, okay? But this base of negative 3 is, and it has a negative exponent. So when we have a negative exponent, we have to take the base and send it down here to the denominator now. Oops. And write out the exponent as a positive. And remember, this is negative 3 all squared, not negative and then 3 squared. So when we square a negative number, we will always get a positive number, and so that would give us positive 9. I'm just going to put a little set of instructions here. Simplify the following. And remember, FFG is shorthand for following. And we will always say leave your answer with positive exponents. But that goes without saying. It's a given that all answers must have positive exponents. Okay. So here, okay, this one looks a bit complicated, but if we just kind of break it down and see what we're looking at, it actually isn't. So here, this is my base, okay, and it has a negative exponent. So for that portion, I can just bring the base up to the top, and I'll have a positive exponent. But remember, our invisible ones, we don't write a power 1. We write a power negative 1, okay, but we don't write power 1. And then over here, this base is being given power 0. So remember, anything to the power 0 is equal to 1. However, you have to remember that this 2 is not affected by the exponent. Okay, that exponent 0 is only touching the base. Okay, and then we have this subtraction, which we're just going to, if we distribute that subtraction, then you're subtracting A and you are subtracting B. So if I'm just to simplify this and remove my brackets, and now we have like terms, so I can go A minus A, which gives me 0, B minus B, which is also 0. So this, which looked very complicated, is actually just equal to 2. Okay. So in this one, what I recommend doing is before you start looking at negative exponents and things like that, you simplify. All right, so always simplify the top, simplify the bottom, and then you simplify the fraction. So here in my numerator, I have a base, so a power that's raised to a power. And I'm not doing anything with my denominator. Now I have a base at the top with a negative exponent, so that base has to go to the denominator. But I have in the denominator, I have a base with a negative exponent, so that's going to have to go up to the numerator. And that will be your final answer. We can't simplify this any further because this is not same base division. It's a division, right? And we have exponents, but it's not same base, so we can't do anything there. Okay. So again here, we have same base division. All right. Yes, we have a negative exponent, but we actually have the same base as we do at the top. So we're going to treat this like same base division. So with same base division, so we're looking at our x base, right? With same base division, we first identify where is the power greater. So at the top, I have a power of negative 8, and at the bottom, I have a power of negative 2. So 8 is greater than negative 2, so we are going to write our base at the top, and then we have to go 8 minus negative 2, not 8 minus 2, okay? 8 minus negative 2, which gives us 10. The 6 stays in the denominator. It does not have a negative exponent there. It's just the number 6, which means the exponent is 1. We don't write the 1, okay? But it stays there in the denominator. So again, remember what I mentioned about we simplify the top, we simplify the bottom, and then we deal with the fractions. So A, there's no other base A at the top, so that just stays there as A to the negative 5. With my base B, however, I'm raising a power to a power. So negative 4 times negative 2 gives me positive 8. And then in my denominator, this base B was just there by itself. So here's now where we're going to deal with the whole fraction. A at the top, there's no other A at the bottom. However, this A has a negative 5 exponent, so we're going to push it down here so we can have a positive 5. B has power 8 at the top, and negative 3 at the bottom, which means power is greater at the top. So we're going to go to the top. We're going to say b to the power. We go 8 plus 3 is 11. Okay, so here we have the base is actually negative 3, okay? So we are saying negative 3 all to the power of negative 3. So it's a negative exponent, so we bring the base down here. Notice the base can't become positive, all right? The base does not change its sign. It's the exponent that changes the sign, okay? And negative 3 to the power 3 is actually negative 27. But we don't write math like this. We don't write a negative in the denominator. We push it up to the top, and that's negative 1 over 27. Okay, we're going to do one more example. Okay, so here we need to match the same bases. When we have strings of multiplication at the top and the bottom of our fraction, we can pick and choose. So what we're going to do here is we are going to first just look at base k. And with our base k, we have power 5 at the top and power negative 3 at the bottom, which means we are greater at the top. So k is going to be up here. And we go 5 minus negative 3, which gives us 8. And then we move on to our base m. Now m at the top has a power of negative 4. But the denominator has a power of 2. 2 is bigger than negative 4. So we're going to go and put the m down here. And then we go 2 minus negative 4, which is 6. And then notice the k and the m, they're not the same bases, so we can't do anything else with it. That's where we stop. And then as a final example, remember, if you have a fraction that you then have a negative exponent to, we just flip the whole fraction over and give it a positive exponent. And then, of course, distribute, or we could just square it as it is, because if we square it, then we have 5 squared over 3 squared. I think we'll do 2 more examples just to give you an idea, just to take you to more of the level that you can expect to see when we do any assessments. Okay, so here, in this situation, like I said again, you always simplify numerator, denominator, and then deal with the whole fraction. So in my numerator, this 8 does not have a power attached to it. My x's, I can see same base. Same base multiplication. So that's going to give me x to the power power 2 if I add those numbers. And then my base y has a power of -10. Now I'm going to deal with the whole fraction. So we're going to have the 8 has nothing to divide it with. It's going to sit there. Base x, powers greater at the top. 2 minus -3 gives me 5. Base y just had a -10 at the top, so we bring it down and make it a +10. So this question here, question K, there doesn't seem to be any same bases. We cannot apply any exponential rules based on what we see here. However, $15 can be written as a product of prime factors. 15 is 3 times 5. And remember, this was not just 15, it was 15 squared. So now what I have in the denominator is the same thing as 15 squared. And now in that denominator, so there's nothing I can do with the numerator. Those are two unlike bases that are being multiplied, but I can't apply any exponential rules there. In the denominator, however, I have multiplication that's raised to a power. So this is power of a product. So everything gets the power. And now we can use our rules because now we have like bases. So with base 3, I now will have 3 squared. And with base 5, I will just have 5 to the power 1. Remember, we don't write the power 1. And there is no need to take this further. You can leave this exactly as is. Okay? And that covers all the styles of questions that you would need to do when we are simplifying exponents.